Welcome to my 16th session, and this is the 5th class on frictional forces and motion. So in the last class we discussed few basics about a free body diagram, and we also discussed what happens when a force is applied horizontally on a body, for one body and for two bodies, what happens to the acceleration. So if you remember, we used a case where there were two bodies. There was M1 and M2, and both the bodies were touching each other. So you can refer to that class. And what we'll do in this class is we'll take a very similar example, but with a slight twist here. So let's now assume that this is our M1, and we have tied these both the masses with a rope, and we are applying a force F, let's say, in this direction. So if you see, it is a bit different from this scenario where both the bodies were touching. And again, for convenience sake, this is frictionless. Okay. Now, so let's quickly draw the free body diagram here. So if this is F, and since this is frictionless, we don't have to bother. There is no friction which is going to be in this direction. Okay, no friction here. So we don't have to bother about any frictional force. But what are the other forces now? Let's see. Okay, now because of this F, what is happening is this entire system is going to experience a forward motion with an acceleration A, and this particular rope here will experience a tension of force T, let us say. Okay, so now let us draw the free body diagram. Okay, for convenience sake, let me just call them as M1 and M2. Let's keep one for the body that is for the body where the initial force is being applied. So now let's draw the free body diagram for this. So let's start with M1. So let me draw this here. So this is M1. Clearly we have a force which is acting in this direction, and there is something trying to resist it. That is the tension of the string. Are there any other forces acting? No. And this is resulting in the body moving in the forward direction with an acceleration A. So based on this, can we draw the free body diagram? Can we draw the equation for the forces? So it's as you can see very obviously, force minus tension, which is in the opposite direction, will result in M1 into A. This is your first equation. Fair enough. There should not be any confusion here. Let's now draw what are the forces acting on M2. So if this is M2, body M2, smaller body, what is the force acting forward? It is the tension. Any other force acting? There's no other force acting on it. No frictional force, no nothing. And what is happening to it? Since the whole system is moving with an acceleration A, this also is moving with an acceleration A forward, right? Therefore this tension, no minus plus anything, is resulting in M2A, force forward. This is your second equation. So we have got both the equations here, equation 1 and equation 2. So now we can quickly solve this. So let us add 1 plus 2. So what will happen is TT will get cancelled. So force will be equal to M1A plus M2A, right? Because T is negative here and this T gets cancelled if you add both the equations. Therefore the acceleration of the system will be equal to F by M1 plus M2. That's it. Very straightforward. And if you want to calculate the tension, Once you find out the acceleration, you can substitute the value of A here and you will find out what is the tension in the rope. Now, if you see, I have taken two bodies here. Now, you can repeat this for any number of bodies. Now, let me give you example with three bodies. Now, let us say I have a body here, three bodies, and I have a force F, right? So this will become T1, tension 1. This will become tension 2. We'll take it as M1, M2, M3. So you can see that I can draw three free body diagrams. So the first one will be, this is M1. So this is force, this is T1, and this is acceleration forward, right? So for the second body, how will the forces act? The second body is M2. This is having a force forward. Now it is being pulled by T1, right? And on the other side it is pulled on the other direction with T2, and the body is moving forward again with A. And in the third case, for our M3, for our M3, yes, what is happening is you just have a forward force which is T2, and the body is moving forward with acceleration A. Therefore, now that we have three equations, if I add equation number 1, equation number 2 and equation number 3, what I'll get is F is equal to M1A plus M2A plus M3A. Therefore, A will be equal to F by M1 plus M2 plus M3. So you see, this is very simple. There is no much complication in this, right? And you can see it is again consistent with this. Therefore, if I have n number of bodies, the acceleration of the system will be nothing but A is equal to the force applied by sum of all the bodies. Now, in these two particular cases, we did not take the frictional force. We did not take any frictional force into consideration. We'll take a few examples of these with frictional force in our next class. But for now, what I want you to do is, please go to your school textbooks, and I want you to read through and understand how they have explained these concepts, because my effort here is to make things very simple and give you a visual explanation of each. I am not getting into too many complications here. The basic idea is, after you go through my lessons, you should easily be able to relate to what is in your textbook, or if you read any other textbooks which are of a slightly higher higher standard, you should be able to easily grasp the idea. So that is what I'm trying to do. So please understand this. We'll have in the subsequent sessions, I'll take number of cases of friction under different circumstances, how friction, acceleration, coefficient of friction, motion, how all these relate under various circumstances, right? So I'll see you in the next class. Thank you.